In this lesson, you will learn the main factors that affect CPU performance. These include the system clock, clock speed, bus width, cache memory, overclocking, and the number of CPU cores. CPU performance. CPU performance is not controlled by one factor alone. A faster clock can help, but bus width, cache size, and the number of cores also matter. The overall speed depends on how these factors work together. System clock. The system clock sends regular timing signals inside the CPU. These signals keep the CPU components synchronized, so instructions and data are processed in the correct order. Clock speed. Clock speed is measured in hertz. 1 hertz means 1 clock cycle per second. A speed of 3.5 gigahertz means 3.5 billion clock cycles each second. A higher clock speed can increase performance, but it is not the only factor. Bus width. Bus width tells us how many bits can travel at one time. A wider data bus can transfer more data in each transfer. A wider address bus allows the CPU to access more memory locations. Both can affect computer performance. Overclocking. Overclocking means setting the CPU clock speed higher than the speed recommended by the manufacturer. This can be changed through BIOS settings. It may make some tasks run faster because the CPU attempts more cycles each second. Overclocking risks. Overclocking can make the computer unstable. Instructions may not finish before the next clock pulse arrives, causing crashes or freezes. It also produces more heat, so extra cooling may be needed to prevent damage. Cache memory. Cache is a small amount of very fast memory inside the CPU. It stores frequently used instructions and data. Cache is faster than RAM, so it reduces the time the CPU spends waiting for information. How cache improves performance? The CPU checks cache before checking RAM. If the required data is in cache, it can be accessed quickly. If it is not there, the CPU gets it from RAM. Frequently used data may then be kept in cache for faster access later. CPU cores. A core is an individual processing unit inside a CPU. Each core contains a control unit, an ALU, and registers. A dual-core CPU has 2 cores, while a quad-core CPU has 4 cores. Dual-core and quad-core CPUs. Cores may need to communicate when sharing work. 2 cores have 1 possible communication link. 4 cores have 6 possible links. More communication between cores can reduce some of the expected performance gain. More cores and performance. More cores can allow different tasks to run at the same time. Programs designed for multiple cores can split work between them. Performance does not always double because some programs use only one core and cores also need to communicate. Exam checklist. Remember these exam points. A wider bus can improve data transfer. A higher clock speed can increase processing speed. Cache reduces access time for frequently used data. More cores can improve performance. Overclocking can cause overheating and instability. Summary. The system clock synchronizes CPU operations. Clock speed is measured in hertz. Cache gives the CPU faster access to frequently used data. More cores can process more tasks, but performance may not increase in direct proportion. Overclocking may improve speed, but it also increases risk. Thank you for watching. Like and subscribe for more IGCSE Computer Science revision. Visit www.tuitionharbor.com or email hello@tuitionharbor.co.uk.